Running in Circles with OSRM and R, and will be delivered by Megan Beckett.
Thanks, Sureshni. So, my name is Megan Beckett. I'm from Cape Town. I'm a data scientist at Exegetic Analytics. So, to get started, 3 things about me that are particularly relevant for this talk. I like green spaces, I like R, and I like running. So, as I'm not from Johannesburg, coming here, whether you're here for work or for travel, and you go to a new place and you want to find out, how do I get somewhere? You probably ordinarily reach for your phone and pull up Google Maps, which I could do, but as a data scientist with a very specific set of conditions and constraints, I want to delve into this in a bit more detail and map out my options. So my tool of choice is OSRM. So OSRM stands for the Open Source Routing Machine, and it's a high-performance C++ engine for calculating the shortest paths between points in a road network. So you could also do these calculations with the Google Maps API, but if you have a local instance of OSRM running, it's orders of magnitude faster than Google, and it's also way cheaper because you don't have to worry about your limits, your daily limits, which you have in Google before you have to start paying. OSRM is used in many applications. I thought I'd just highlight a few. This is one, cycle travel. It's for defining and figuring out cycle paths specifically for people doing long tours throughout the UK and Europe. Mapbox is a whole set of tools for developers specifically, and a lot of their services use OSRM for their routing. This was another one that I found. It's a ride-sharing service in Morocco, and they use OSRM for plotting out their routes. And then lastly, if you ever find yourself in Oklahoma and you want to find your nearest marijuana dispensary, you can use this map to find your local store, and they use OSRM server to plot this out as well. So all of these applications are using an OSRM server, but what I want to show you is how you can get your own local instance up and running. So this is a high-level overview. This gist is also available on GitHub if you want to go and get it. And I'm setting up for a Linux infrastructure. So firstly, you need to just get some of the infrastructure that you need and other software. Then you can grab the source from GitHub. And then you need to create a build folder and run the make file. So this takes some time, so go grab a cup of coffee. And lastly, you can run sudo make install to actually install your OSRM server. Alternatively, you can also go and grab the Docker image for a much easier setup and installation. So once we have OSRM installed, we then need some data. So you head on over to OpenStreetMaps, and what I've done here is selected an area that I'm interested in, which is the city of Johannesburg. And you then click Export on the left-hand side, and this will download the OpenStreetMap data for this bounding box. You might run into this notification, which is telling you that your query is too large to query directly from the OpenStreetMaps API. So they're pointing you to alternatives where you can download from a clone, for example, Planet OSM, the Overpass API, and one that I also experimented with specifically for this talk is GeoFabric, and you can select a whole region, for example, the African continent, or download the OpenStreetMap data for South Africa, which is what I did, and it comes as a compressed file. Once you have your data, we then need to actually prepare it, and this is when we start using OSRM. So the first decision you need to make is what mode of transport you're going to be using to traverse your road network. And OSRM comes with 3 default profiles, so whether you're going to be walking on foot, traveling by car, or riding a bicycle. And the purpose of each of these profiles is that they set average speeds that you're going to be traveling on, whether there are constraints about certain paths that you can or cannot go down. For example, pedestrians can go along a lot more routes than a car could. So you extract your map data, and then you need to create the hierarchy. So you use this function OSRM contract, and what it does is calculate all the shortest points between your road network according to the profile and speed profiles that you have. So depending on the amount of RAM that you have on your machine, this can take some time. Once that's done, you're now prepared to actually launch your service. And you run this using the command OSRM rooted, pointing to your map data that you've just prepared. So once we have this running, I want to check, okay, is it actually working as I expect? So my first point that I made, I like green spaces. So I wanted to see how far to walk from here at the Discovery Center to our nearest park. So this is Innisfree Park, which is just down the road. And if you're there and looking back towards Discovery, this is the view you'll see. So what I do is in the terminal, issue a curl request. And I'm pointing at my local server running, that's the address, specifying the route, which is the service I'm going to be using, the walking profile, and then my only other two inputs for the route service are the start and end coordinates for my 2 points. And this is my result that I get back. I've highlighted those 2 lines, so you can see first it picks up where we're starting from, which is Discovery Place, and secondly, where we're ending is Grayston Drive, and that's the address that Innisfree Park is at. Scrolling down a little bit, I then get the information about the route. And I've also again highlighted the 2 key pieces in here. And that's the distance, which it gives us in meters, so it's about 2.7 kilometers. And it estimates that it's going to take us about 1,900 seconds to walk there, so just over half an hour, which seems about right. So now that I've tested and validated that my OSRM server is accurate and giving me results that I expect, if you remember my second point, I like R, so I'm going to head out of my terminal and straight into R as soon as I can. We could carry on doing these API requests in the terminal, but fortunately for us, we have the OSRM package, which exposes all of these services from OSRM for us to use in R. So the map on the right, is our location that we're staying at in our B&B. And I have 2 important questions that I wanted to answer before this talk. Firstly, what's the optimal route to visit the parks in the surrounding area of our B&B? And secondly, what can I possibly see within certain time intervals from our B&B? And if you remember my third point, I like running. So I'm going to be doing this with my running shoes on. And my first step I need to do is I cannot use any of the default profiles that come with OSRM. So what I did was design a custom profile for myself, setting running speed, so for example, 5 minutes per kilometer or 12 kilometers per hour, that I want to traverse this road network. I then extract the data again and launch the service. So now that I've got this service running, that will predict and estimate my running times. So in R, my first question is, what's the optimal route? And this is just a high-level summary of the code. I've also created a notebook online that you can go have a look at. The link is bit.ly/satRday-OSRM. And you can check out the code in more detail and also what these plots look like. So just to highlight, we load up our packages, OSRM leaflets and dplyr that I'm using. You point to your OSRM server that you have running locally. And then I need to supply it with a data frame of points. So I went and looked up what are the coordinates of the parks in the area that I'm interested in, and you create this list. It doesn't matter what order they're in. That's what the purpose of the trip is going to do. The key function I'm using here is OSRM trip. And all I need to supply it is this data frame of points. And what it's going to do is determine the optimal shortest route round trip that I can take to visit all of these points, and also give me some information about it. I've then used leaflet to plot the data, and specifically using add poly lines because the output of OSRM trip is a spatial lines data frame. And this is what it looks like. So you can see at the top over there is our B&B, and then the first stop is Innisfree Park. And this is the shortest route that I could take to go and visit all the green parks from our B&B. And we also get additional information from OSRM trip. It'll specify each leg in this trip, the distance and the estimated time. And the total trip distance is about 33 kilometers. And it's estimating about 165 minutes. So I think that's a good one for me for my long run. Secondly, what can I see within certain time intervals? So to do this, I'm going to be using a concept called an isochrone. So an isochrone is a line that's connecting points on a map that have the same travel time from a central location. So again, I load up my libraries, I point to our OSRM server. Now I only need to supply one data point, which is one coordinate, which is the B&B location, and that's going to be the center of our isochrones. The key function that I'm using here is OSRM isochrone. I could just generate one isochrone, but what I want to do is specify certain time intervals. So that's why over here I've got the breaks in sequences from 0 all the way to 30 minutes by 5-minute increments. This result argument determines the sort of the depth of the pixels and how accurate your map is going to be. And this takes some figuring out in terms of and playing around with to get the optimal map that you're looking for. And then I plot it again with leaflet. This time I'm using add polygons because the output that we get is a spatial polygons data frame. And with a little bit more customization in leaflet, this is what I plotted. So you can see the central location, which is our B&B. And I now have these polygons which define the area that I could cover in 5-minute increments of travel time, which for me is with my running shoes on. And I've also color-coded it in perceived level of exertion. So the further I go, the harder it gets. So if I was to travel all the way to the outer points of the map, it would take me half an hour and half an hour to get back again. So these are some applications which are of personal interest to me. But at Exegetic, we've used OSRM and several projects for clients on spatial optimization problems. For example, in a security company to figure out the optimal placement of their vehicles so that they have a good response time to customers and the call-outs. We've also designed routes for courier services across the United States. And then an example that I wanted to just highlight that I worked on not too long ago was for a company where I had to come up with this idea of a delivery area compromise. So this is a retail store. This is just one example. This is in Sea Point in Cape Town. And the store has products that they want to deliver to their customers. They say that they want their products to reach the customers within 8 minutes when the customer orders. So what I did, that's easy to do. We can plot an 8-minute isochrone using OSRM. But then the actual delivery company said that they're not interested in the time. They don't want their delivery vehicles to travel further than 2.5 kilometers from the store. So this is not an isochrone, and it's a less common term known as an isodistance, which is not something that comes automatically with OSRM. But what we did was actually, again, create a custom profile where we defined the walking speeds, or actually it was on motorbikes, so driving speeds of 2.5 kilometers per hour. We then set the time interval to 1 hour. So then I know that the outer limits of this polygon that I get back will only be a distance of 2.5 kilometers. So that's what I plotted there. Next, we then needed to come to some sort of compromise between the actual store and the delivery company. And to do so, I created this intersection using the SF package. And everyone is happy that we've got a delivery area for customers that's either 8 minutes or 2.5 kilometers, whichever comes first. So that was a pretty neat application that we did. And I created these polygons for all of their stores around South Africa, which they now use in their app so that a driver or a customer has to be within this area to order from this specific store. So in conclusion, first of all, who's keen for a run tomorrow morning? And secondly, these are my contact details. If you're interested at Exegetic, we love doing spatial optimization problems, so please do get in touch. And do check out the notebook that I have online and ask any questions. Thanks.